Now, let me talk about a couple of priors that are recommended by experts out there. So one is a prior recommended by Andrew Gellman, the leading author of Bayesian data analysis. One time, his team and he recommended this student T, okay? So he and his team argued that, well, the best choice for beta would be student T, prior, I'm talking about. And new here is degree freedom. And they recommend, we better pick new between 3 and 7, excluding the 2 boundary values, okay? And also the name is 0, and S is chosen to provide weak information on the expected scale. So S is the scale parameter. S is the scale parameter, okay? And we say, provide weak information, and that means, well, S needs to be what? A large number, a large number. Well, however, Andrew Gellman in his 2008 paper titled "A Weakly Information Default Prior Distribution for Logistic and Other Regression Models" states that assuming that non-binary variables have been scaled to have mean 0 and standard deviation 0.5, then student T prior with degree freedom equal to 1, location parameter equal to 0, and scale parameter set to 2.5 is recommended. And this is what is called Cauchy distribution, because when the degree of freedom for student T is equal to 1, that is equivalent of a Cauchy distribution. So this is his 2008 recommendation. But later on, he and his team updated their recommendation. So this is the newest recommendation. But these are not only recommendations that Andrew Gellman himself makes even. Gellman, on one of the website where the STEM team talks about prior, primarily Andrew Gellman. The page is titled Prior Choice Recommendation. He notes that, as noted above, we've moved away from the Cauchy. And I, that is Andrew, am now using default normal for R, STEM R package, okay? And usually he uses normal for my own work. Normal 0, 1. So the location parameter that is mean is 0, standard deviation is 1. All right, so that is considered to be, weakly informative prior in his own work. He continues, I think the right way to think about the Cauchy is that it's a normal with an unknown scale. So it could be appropriate if applied in a setting where the prior is on scale and where we have no idea what are the scales of the problem at hand. In a real-life problem, the user should have some sense of scale. In a completely blind problem, for example, you're running some sort of automatic feature detection program, you should be able to do some rescaling. Okay. Since I talked quite a bit about t-distribution and Cauchy distribution, so let me get into a bit of detail about some statistical as well as mathematical properties of these two distributions. So for student T distribution, well, there's a long story about why this distribution is called student T, but I won't get into such details. So it has a parameter called nu. Is for degrees of freedom. It has to be greater than 0. And here is its probability density function. So this is a random variable, right? This is mu, okay? And this is a gamma function. And it's used twice, right? Gamma function first in this as this numerator, and also it is used also in the denominator. Okay, and its expectation is 0 for mu greater than 1. Otherwise, it's undefined, and its variance is equal to mu divided by mu minus 2. That is for mu greater than 2, or it becomes infinity for mu between 1 and 2. For mu between 1 and 2. Okay, when mu equal to 1, then we have this probability density function 1 over pi multiplied by 1 plus t raised to the power of 2, a special kind of Cauchy distribution with location parameter set to 0 and the scale parameter set to 1. So Cauchy distribution has 2 parameters for random variable x. So let's say its location parameter is x0 and scale parameter is gamma. Then its probability density function goes like this. Okay, 1 over pi gamma multiplied by bracket 1 plus parenthesis x, then the ratio, right? In the numerator, it's x that is random variable minus the location parameter divided by gamma, the whole term squared, right? And while both of its mean and variance are undefined for Cauchy distribution.